We're going to take a look at ways to classify reactions just as a quick review. Remember that there are driving forces that start reactions, and some examples of those are the formation of a solid, which we know is a precipitation reaction, formation of water, which is an acid-base reaction, the transfer of electrons known as oxidation, reduction, or redox reaction, and the formation of a gas, all evidence of reactions and driving forces for a reaction. Okay, let's look at precipitation reactions. Remember, we get a precipitation reaction when we have two aqueous solutions that go together to form a solid precipitate. And we see that here in this example. The solid is formed, barium chromate, after potassium chromate and barium nitrate being put together. Both of them are aqueous. So we have aqueous plus aqueous. We have a solid formed and aqueous. This is known as the double date switch, and we show examples of this by writing this general formula for it. And there are a lot of double date switches. The acid-base reaction can be a double date switch, but this one is known as a precipitation because it does form a solid. And remember that we look at our solubility rules to find out what products are solid and what are not. Acid-base reactions. We have a net ionic equation for an acid-base reaction that is always H plus OH minus yields H2O liquid. So our overall reaction, not our net ionic, but our molecular reaction, our ionic reaction in this case actually is hydrochloric acid, which is our acid, plus potassium hydroxide, which is our base, and we have liquid water as our product, and a salt, and this salt happens to be potassium chloride. So that's your acid-base reaction. Oxidation reduction reactions show a transfer of electrons, and you'll see in this example, lithium by itself, just a chunk of lithium, is going to have an overall charge of 0. Fluorine molecule has an overall charge of 0, but when I react them together and form lithium fluoride, lithium is, because an ionic compound, lithium forms a +1 charge, fluorine forms a -1 charge because it takes the electron from lithium. Lithium gives its electron up, so it's a transfer of electrons showing evidence of an oxidation reduction reaction. Formation of a gas is a type of redox reaction. Single replacement reaction is a type of oxidation reduction reaction as well. So in this case, we see a single replacement. This is zinc by itself, and it goes home with chlorine instead of hydrochloric acid staying together, and it goes home by itself. So single replacement reaction is an example of a redox reaction. Combustion reactions generally include plus O2. That's what we're going to look for to identify it as a combustion reaction. And it always forms heat, and a rapid flame usually is what's indicated. But one of the things I want to bring out, and I brought this up last year, it's one that you have to remember. Anytime you have a hydrocarbon, that's a hydrogen and carbon combination, and you burn it in oxygen, always your products are going to be carbon dioxide and water. So it's just one of those things you need to remember. Combustion reactions are special redox reactions. Synthesis is just putting two single things together and coming up with a compound. This is also a redox reaction. Decomposition is the opposite of synthesis. This is when you have one compound broken down into its elemental substances. That's also a redox reaction. So if we're going to take a look at the overall flow chart for this, we classify all chemical reactions based on whether they are acid-base, oxidation reduction, or precipitation reactions. And then those oxidation reduction reactions can be further divided into synthesis, decomposition, and we can identify them as combustion as well. So let's take a look at this example real quick. The reaction between hydrogen and oxygen forms water, and how do we classify this? Do we classify it as a redox reaction, which it is because we have evidence of synthesis. So we have one with the 0 charge, one with the 0 charge, and a very polar covalent bond within water. It's a synthesis reaction because element plus element yields a compound, and it's combustion because we have the plus O2. So the only answer for this one is D, all of the above.